Hello, welcome you all to a new video. Today we are gonna see concept of random variables, that is discrete and continuous. Well, a random variable is a variable whose value is determined by the outcome of a random event. Discrete random variables represent countable outcomes while continuous random variables represent measurable outcomes. Let's explore their applications in real life. Random variables that can be categorized in discrete or continuous. Understanding the properties and applications in real life is essential. Then we have the discrete and continuous variables. And the random variable is a variable whose values is determined by the outcome of a random event. Discrete random variables represent countable outcomes while continuous random variables represent measurable outcomes. So what is a random variable? It is a numerical value that represents the outcome of an uncertain event. It can take on indifferent values based on the result of the event. So, understanding random variables is crucial in various fields like finance, statistics, and decision making. And we have discrete random variable. Those are that can only take on a countable number of distinct values, such as the number of heads obtained while when flipping a coin. Then what is a discrete random variable? Discrete random variable represents outcomes that can be counted and have distinct values. Examples include the number of heads in coin or the number of cars passing through an intersection in a given time period. Now we see the real life some applications of discrete random variables in everyday life. First one is rolling dice. The outcome of rolling a pair six-sided die can be modeled as a discrete random variable with values from 1 to 6. Second is survey responses in market research. The number of people who choose a particular response can be considered a discrete random variable. We have website traffic. The number of visitors to a website in a day can be modeled as a discrete random variable. Now we have properties of discrete random variable. Here I have taken a graph on the left side. So seeing the properties of discrete random variable counting countable values. Discrete random variables can only assume specific separate values often represented by integers, finite or infinite. The set of possible values for a discrete random variable can be finite or infinite but countably infinite. We have probability mass function. The PMF of a discrete random variable gives the probability of each possible value it can take. Now, the examples of discrete random variables in real life is rolling a dice, number of children, customer arrivals. In rolling dice, the outcome of rolling is a discrete random variable. In a family, the number of children is a discrete random variable, and the number of customers arriving at a store within a specific time period is a discrete random variable. Then we have continuous random variable. A continuous random variable represents the outcomes that can take on any value within a range. Examples include the height of individuals, the time it takes for a machine to complete a task, or the temperature outside. Let's explore some applications of continuous random variables in real life scenarios. The important one is stock market. The price of stock is at a given time can be considered a continuous random variable. Weather forecast, the temperature recorded at different locations throughout the day can be modeled as a continuous random variable. And the traffic congestion, the time it takes to travel from one place to another can be modeled as a continuous random variable. Then we have properties of continuous random variables. The left side has the graph of continuous random variable. The first one is properties infinite possible values. Continuous random variables can take on an infinite number of values within a defined range. The probability density function, the PDF of a continuous random variable gives the relative likelihood of different values within a range. And we have non-countable set of values. The set of possible values for a continuous random variable is non-countable, such as the heights of individuals. Then we have examples of continuous random variables in real life. Age distribution. The age distribution of a population is a continuous random variable. The temperature variations. The temperature measured at different times is a continuous random variable. And the rainfall levels. The amount of rainfall in a specific area over a given period is a continuous random variable. Then the importance of understanding random variables in decision making. Random variables play a crucial role in decision making by providing insights into the probabilities associated with the different outcomes. Probability distributions, expected value, and variance are key concepts in understanding and analyzing random variables. Probability distributions. By understanding the probability distribution of a random variable, we can evaluate the likelihood of different outcomes. And we have expected value and variance. The expected value represents the average value of a random variable, while variance measures the spread of its possible values. So, in conclusion, I would like to conclude by the concept of random variables, both discrete and continuous, is fundamental in various domains. By understanding and analyzing random variables, we can make informed decisions and gain valuable insights into the real life scenarios.